Australian printmaker Judy Barrass. This video takes you through the steps of making a 3D printed relief plate for traditional printmaking, from a drawing on paper to a finished plate, using free, easy to use and readily available software and the Makerspace Prusa 3D printers. The instructions are for beginners with no experience in 3D building or printing. Each part of the process is explained from the drawing to the final plate, and the video is divided into clearly marked sections so you can pause and complete each of the tasks as you watch. When you see this little animation, the video is about to go on to a new task. So let's begin. We're going to start with a black and white drawing, which will convert into a relief plate. In the demonstration, I'll be making a finished plate around 11 by 7 centimetres. If you're going to follow along, it would help if you make your drawing roughly in proportion to this. The drawing needs to be black and white, with no tone and no hatching. Clear, solid lines. Blocked out areas of black are okay. If you're drawing on paper, use a good quality black pen. I find the fine Sharpies give a good solid black line, but many other pens will also be suitable. Keep in mind that if you're drawing on something like an A4 sheet, the lines will reduce in size when the image is reduced, so use a thicker pen or draw only to the size of the plate. The design needs to be relatively simple, especially for your first attempts, so try for less detail. Think of designs that would suit simple lino cuts or stencils. This is the drawing I will be using for the demo. The next step is to scan your drawing and save it as a JPEG. Remember to scan in black and white or grayscale with good contrast. Scanning at 72 pixels per inch is probably enough for the purposes of this exercise. If you don't have a scanner, you can download one to an iPad or a smartphone, and that will give you a better image to work with than a photo. Next, we need to convert the JPEG image to a vector or SVG file. There are quite a few free online converters available. Do a search using something like Convert JPEG to Vector and you'll find them. I've used a site called Convertio. Make sure that you convert your file to an SVG. Then download the file and save it to your project folder. To make your drawing a 3D object, we'll be using the free web-based software Tinkercad to convert your drawings. It's free and very easy to use. It's web-based, so you use it online and don't have to download anything. Go to the Tinkercad site and create an account and then log in. All your projects will be stored on this start page. This is the screen you'll meet when you open a project in Tinkercad. We're going to ignore a lot of it and just work on the things needed for our project. Up in the top left, you'll find Tinkercad has given your project a temporary name. Change this to one you'll remember. You'll need to understand just a few simple controls to manipulate your view of the work plane. Have a look at the column on the left-hand side. You can always come back to the home view by clicking on the little house button on the left column. Your view can be manipulated by clicking or dragging the box on the left side. Try it. It can be a bit weird if you're not used to working in 3D. Our first task in Tinkercad is to make the base of our relief plate. On the right-hand side, you'll see a column of shapes. Find the solid red box in the top right of that column. Click on that red box and drag it into the middle of your work plane. That will be the start of the base. If you click on the red box, its measurements will appear. The measurements on the grid are millimetres, so the default box is 20 mm high and 20 mm wide. That's just 2 centimetres square and not the size we want. When you click on the red box, a drop-down menu titled Box will also appear on the right. Move your cursor to that menu to change the measurements. For a portrait-shaped base, click on the length and change the value to 100. Click on the width and change the value to 70. For a landscape base, reverse those numbers. Click on the height and change the value to 0.6. Pan out and admire your work. Congratulations, you've made the base. Now we need to import your drawing. In Tinkercad, with your base plate project open, choose Import in the top right-hand section of the screen. A dialog box will open. Click on Choose a File, and from your project folder, import the SVG file of your drawing. Make sure you choose the SVG version. Depending on the size of your scan, that SVG file might be too big for the small base we've created. Don't panic. Ctrl-Z will always undo your last step, or if you're using a Mac, Command-Z. So if your drawing looks gigantic, hit Ctrl-Z and start the import process again. In the dialog box after you select your drawing, there's provision to resize your drawing. I chose to import my drawing at 30% and that worked out pretty well. Your requirements might be different. Make a guess as to how much it needs to be reduced and import the smaller version. Now that you have your drawing on the work plane, use the box in the left-hand column and switch to top view so you are viewing your plate from above. To move or resize your drawing, make sure you always click on the solid part, otherwise you'll be changing the base below. If your drawing is not on top of the base, click on the solid part of the drawing and move it onto the plate with your cursor. When you click on a solid part of your drawing, controls to resize will also appear. Hold down the Shift key and move the handles to resize your drawing in proportion. Resize and move it to fit neatly on the base. If, like my drawing, yours doesn't quite fit the proportions of the plate, you can either center it on the plate or resize the base plate. To resize the base, click on the red base plate, not on the drawing, and use the handles to resize. The next step is to change the height of your drawing. Use the box on the left to slightly change your view. Click on a solid part of your drawing so you can see both the small white box and the black tear shape in the center of your drawing. Click on the small white box, move to the measurement that appears and change it to 1.5. Right now, your drawing is sitting on the same plane as the base. We are going to move it up just a bit. Click on the small black tear shape just above the white square in the middle and change the value to 0.4. Our plate is now looking pretty good, but it's still in two parts. To meld it together into one object, Click and drag your cursor across the plane to select both the drawing and the base. Then choose the group symbol on the top right. Your plate will now be all one colour. The final task in Tinkercad is to download the file that contains the 3D object you've just made. That will be an STL file, ready for the next step in the process. Choose Export in the top right hand of the screen and choose STL in the box that appears. Save the file and find it in your downloads and add it to your project folder. If you don't have access to a 3D printer and will be asking a printing service to print your plate, this STL file is the file you will take to the printer, and you can stop the video here. 3D printers operate by building up objects in layers bit by bit. They start at the bottom and build up layer upon layer until the object is complete. Before we can print your plate, we need to use what's called slicing software to tell the printer how to make those layers. In the library Makerspaces, we have Prusa printers Mark III, and the following directions will be how to slice and print your plate using those printers. There are other types of 3D printers. If you don't have access to a Prusa printer, for many brands you can still prepare your plate for printing using the Prusa Slicer software that we'll be using. In Google, do a search for Prusa Slicer software and find the official Prusa site. The software is free to use. Download the version for the operating system on your computer, Windows or Mac, and install it on your computer. Open the Prusa Slicer app. This is the Prusa Slicer interface. You can move the work plane around to change your view with your mouse and left mouse button, or move the plate with your mouse and right mouse button. Zoom in and out with the I and O keys on your keyboard or the wheel on your mouse. To bring your 3D plate into the slicer, choose File and Import from the top right-hand side of the interface and import your STL file. Your 3D object will appear on the work plane. Now we want to create a code for the printer. On the right-hand side of the interface, you'll find all the print setting instructions. We are going to use the simplest instructions for this first plate, so make sure Simple is selected right at the top. Then change the values: print setting to 0.2mm quality, filament to generic PLA, which is what we use in the Makerspace, supports to none, and infill to 80%. When you've done this, right at the bottom of this menu, click the button that says Slice Now. The slicer has now created the G code, which is the instructions for the printer. The slicer will also tell you how long it will take to print your plate. Click on Export G code and save your file in the project folder. We're now ready to print the plate. To load the G code into the printer, you need to save it to an SD card. There are SD cards in all the printers in the Makerspace, or you can bring your own. Before you start, clean the printer base plate with spray alcohol and cloths which are provided. Make sure the power is on at the power socket and insert your SD card into the side of the orange box at the front of the printer. Push the center of the orange button on the box to turn on the printer. Make sure you don't flick the lever as you press the button. The contents of the SD card will appear on the small screen. Move the lever on the button clockwise to find your file and press the button to select. The printing plate will need to heat up first, then it will take quite some time to print, but don't run off to get a coffee until you're sure it's all working properly. If it's all going wrong, push the orange button. Stop Print will appear. Confirm yes. When your print is finished, wait a little while it cools. Then remove the whole base plate. Flex it a little to remove the printed plate. There may be stray pieces of filament on your plate that you can remove with the clippers provided or with tweezers, and you will need to give your plate a light sand with fine sandpaper. And that's it. Your plate is ready to ink up. Here is my plate and a few of the prints I've made from it, some with Japanese papers used for shinkalei. If you're a printmaker, you'll already know how to ink up and print your plate. I've found that these plates print best with slightly damp paper. Good luck. There's always friendly staff on hand at the library Makerspace if you need more help.